We've seen the basic first subcommand for frame called variable, but LLDB's frame command can do much more than this. To demonstrate, I'm back in the So Many Bugs app, and we're paused at the handle single tap method that we've seen before, and this is in the breakpoint bug view controller. From the console, we can look up information about LLDB commands, including frame, by typing help. So I'll delete this and type help, and I'll just go ahead and scroll through all of this so that you can see the entire output. We have all of the commands, and then there are command abbreviations like the FR and the V that we saw earlier that you can see for the different commands. And I'll stop here for frame, and here's the information we have. It says that frame provides a set of commands for operating on the current thread's frames, and by frames it means stack frames. So to get more specific help information about frame, I can type the command frame followed by help. This delete button clears out the console, by the way, so that's what I clicked to do that. We'll go frame help. And now we can see that frame supports the following subcommands. So there's the variable command that we used earlier, but it also supports info and select. And at the bottom it says for help on any particular subcommand, we can type help, the command, and then the subcommand. So for example, help frame variable should give us the help information about the variable subcommand. But we've already seen the variable subcommand, so I want to try the two others. So I've stopped the application and I've kind of reset up our debugging environment here. I've set a breakpoint at the add bug to view method, and there are no other breakpoints in the particular app, and this is for the breakpoint bug view controller, and I've triggered this breakpoint again by just tapping on the screen. So let's type frame info, and we can see that the output shows that the current frame is frame 0, and this is for the add bug to view method. And this mirrors what we have in the debug navigator, which is frame 0, and frame 0 is for the add bug to view method. And to switch to current stack frame, we can use the frame select subcommand followed by a frame number. So I'll select frame 1. And just like that, Xcode jumps us to stack frame 1, which is for handle single tap here. And you can see that it's jumped us here in the code area as well. And this is pretty neat. It's not really that much different than what we can achieve by just clicking around in the debug navigator, but you can do the same thing here in the console by just selecting different frames. So now let's really unleash the power of the command line and do something that you can't already do in the graphical interface. And we'll do this with the expression command. The expression command lets us run Swift expressions in the current debugging context, so this is actually really cool. This means we can do things like run methods or even change the values of variables while our program is paused. So I'll start typing the command expr, which is an abbreviation for expression, followed by println and bugs. So this is just like the println statement that we could put in our code. You can see that currently bugs is empty. So I'll go ahead and continue a couple times so that bugs contains some things. And actually I'll turn this off. This breakpoint off, hit play so it runs all the way through. We should have way too many bugs now. Turn the breakpoint back on, and I'll reach again. Let's run the same expression. We can see that our bugs array is very full now that we have all those extra bugs that have been created. So that first expression for just printing, that's pretty cool, but let's try something a little bit more fun. We can actually empty the bugs array. So to do this, we'll use expression self.bugs .remove all, and this takes a argument keep capacity, and we'll specify this as true, and we'll hit enter. And now when I run this expression, it appears that it's completed, but we don't see any updates visually. If we go back to the simulator, there's nothing here. And this makes sense because we're paused at a breakpoint after all, so because we're paused, none of these changes have taken effect. But if the expression did run, we can quickly check while we're paused by printing the bugs array again, and we can see that it's now empty. And if we were to step over, we'll see that we drop right into the if statement, which also further validates that the bugs count is now 0, or the bugs array is empty, and that is less than the maximum bugs. So now we're dropping right back into that if statement. So we were able to change things on the fly to alter the execution of our program. That's pretty cool. And I'll hit play and continue back, and there we go. More bugs are created.